Radiation is energy. It comes from many sources: the sun, the earth, the foods we eat, consumer products, medical treatments, and even from our own bodies. People have always been exposed to radiation.
Radiation is just exotic and foreign to most people, and they seem to have, there's so much disinformation about it, and they come in with preconceived misconceptions about radiation.
Roughly 80% of the radiation to which we are exposed comes from natural sources, such as radioactive elements in the Earth's crust and constant showers of cosmic radiation from space. Because this background radiation is a normal part of the environment in which we live, our bodies are capable of handling low levels of radiation on a day-to-day basis. Human use of radioactive materials for our benefit accounts for the remaining 20% of our exposure. Radiation is used in medicine to create X-ray images and in the treatment of cancer, in consumer products such as lantern mantles, color televisions, smoke detectors, and even dentures.
The problem is people's first introduction to radiation was through a weapons program. Now, I always use this analogy. If you had never seen electricity before, and they took you up to the federal prison, and they brought a person in, a murderer, and set him down and electrocuted him, and then they said, hey, we're going to put some of this in your home, you'd say, you're not going to put that in my home. Well, that's the way that people were introduced to radiation.
Because of radiation's enormous energy, it has been used for weapons. During World War II, the United States developed the first atomic bomb. Atomic weapon production continued during the Cold War period. Sites at Oak Ridge, Tennessee, Hanford, Washington, and Los Alamos, New Mexico were active for decades. Many tons of radioactive waste were generated, and many acres of land contaminated. Now, a great cleanup project is underway at those and similar sites.
The operating engineers have been involved with the Department of Energy, or the Atomic Energy Commission in those days, since its inception. The Manhattan Project, it was probably one of the biggest construction programs in the history of the United States, and many operating engineers were on the ground floor in construction, over the years in maintenance and operation and in actual production. The operating engineers are the #1 trade that's being looked to address these cleanup problems.
There are 3 types of ionizing radiation that are commonly encountered on the job: alpha, beta, and gamma. Alpha radiation particles, which are quite large, can be stopped easily. Alpha radiation cannot penetrate a piece of paper or even human skin. Beta radiation particles are small and can be stopped by a thin layer of metal or plastic. Gamma, the most penetrating radiation, is different. It is a ray and not a particle. Lead and concrete shielding are used to stop gamma rays. Neutron radiation, the 4th type of radiation, normally is encountered only at nuclear reactors or when nuclear weapons are exploded. We cannot see or feel ionizing radiation, but we can experience the effects of radiation, and we can measure it with instruments. People who work routinely with radiation wear their own monitoring devices called dosimeters to keep track of the amount of radiation exposure they're receiving.
With radiation, it's not one big explosion where you see the purple haze, and then you're glowing in the dark. It don't necessarily happen like that. It's what you get every day over a period of time.
The damage to living tissue from radiation depends on the amount of energy transmitted to cells and the number of cells struck. This, in turn, depends on the type of radiation and the dose. Scientists are able to predict with some certainty the results of exposure to high levels of radiation. At lower radiation levels, the results are much more difficult to predict. For low radiation doses, it is cell damage, not cell death, that is harmful. A dead cell may be replaced, but a damaged cell may replicate and multiply. Exposure to radiation is measured in units called Roentgens. A measuring unit, called a REM, short for Roentgen Equivalent Man, is commonly used. This unit indicates the damage potential of an exposure based on the type of radiation. A radiation dose greater than 100 rems can make you sick. Established dose limits are well below the level where damages are observed. The annual radiation dose limit of 5 rems is rarely exceeded in the workplace. Contamination is radioactive material in an unwanted place.
Hey, Leonard, I found some contamination on my clothes.
Radiation is a type of energy. Contamination is a material.
The thing about radioactive contamination is, as opposed to chemical contamination, it's detectable. For a lot of people working with chemicals don't really know what they're getting into, where with radioactive contamination it can be monitored and you actually know what distances you need to be working at and how to deal with this type of contamination.
Today, extensive measures and procedures are taken to minimize human exposure to radioactive material.
Most of the contamination hazards would be an inhalation hazard. This is where the radiation protection people come in. They do extensive air monitoring, and before they let you in a room, they have an idea of what the potential for internal exposures are. And if there's real strong inhalation possibilities, they'll put you in fresh air or self-contained breathing apparatuses and things of this nature.
Radiation protection organizations operate under ALARA, the as low as reasonably achievable concept. The basis for ALARA is that there should not be any occupational radiation exposure to workers without an overall benefit from the activity. The 3 basic practices used to reduce exposure are: reduce the time spent near a radiation source, stay as far away as possible from the source, place shielding between you and the source. Using the ALARA principles will help keep you safe when working with radioactive materials.
Number one, the controls are there for them. They need to listen to what the radiation protection people tell them. However, that's not a monologue. They need to ask questions. They need to make sure they're informed. If they feel uncomfortable, they need to say, hey, I'm not comfortable on that. You need to explain this a little better, and we need to step back, be informed, but also be inquisitive. And that is their right legally also.
Training is essential. Of course, you're going to get good training anyway before you're going to be doing any rad work. With radiation, as with any type of contamination, you're using the buddy system. There's ongoing monitoring. You're never going to be working in a zone alone. So everybody is looking out for one another.
Well, training is the answer to almost everything. Training and education. The worker, the operating engineer who is trained and well educated will be able to protect himself, because we don't want our workers to be scared of these types of industries because there's potential hazard there. The D&D work that will be a industry for many, many years to come. Department of Energy, Department of Defense, the Nuclear Regulatory Commission will spend billions and billions of dollars cleaning up these facilities, and educated operating engineers, heavy equipment operators will enjoy a boom in this industry for probably the next 30 years.